Okay, 1.6, determine a quadratic equation given its roots. Okay, so we're going to review a family of functions. So functions that have a common property are called a family. Okay, and usually what this property is the x-intercepts. Okay, so in grade 9, we worked with families of linear equations that have the same slope, which are parallel. Okay, that's just an example. Okay, but for quadratic relations, this is where the x-intercepts come in, and the subsequent years of math that you'll have. So parabolas are part of the same family that have the same x-intercepts, right here and here. Okay, the three graphs, or the three parabolas in the graph here, are the same family of functions, all with the same x-intercepts, but different a values. Okay, so here are two notes. The zeros can be used to find the equation of a family of quadratic functions with the same x-intercepts. To determine an individual quadratic function, you must be given two x-intercepts and one other point that lies on the parabola. Okay, so here are the steps for solving for a, for like the a value in a family of quadratic curves. Okay, because up here, like these two quadratics are going to have like a positive a value, right? And this one in here, since it's stretched out, is going to have a larger a value, for example. And then this one opening down is going to have a negative a value. Okay, so number one, sub in the x-intercepts to the factored form of the quadratic equation, and then this is the factored form. Okay, and we know that r and s are the factors. So, and then we sub in the given point, x and y, and then we solve for a. Okay, and then if it asks for the actual equation, we always want to rewrite the actual equation. Okay, so let's take a look how this is actually done. Okay, example 1, find the equation in factored form for a family of quadratic functions with the given x-intercepts, and then sketch each family showing at least 3 members. Okay, so we're always going to start with y equals a, x minus r, x minus s. So we can go ahead and write that for each one of these. Okay, so for a, we have two x-intercepts. They're 4 and negative 2. So we can go ahead and sub in 4 to the first bracket to r and negative 2 to s. Okay, and we can simplify the negative 2 as x plus 2. Now, this is a family of functions because we still have a, which is the general form. So we don't know what the stretch factor is on it or if it opens up or down, but that's okay. The two x-intercepts are 4 and negative 2, and 3 possible ways that we can draw this is opening up, opening down, pretend that goes through, and maybe opening up skinnier. Okay. Now let's go to number 2. Okay, so let's sub in 0 and negative 5, x minus 0, x minus negative 5. Okay, and then x minus 0 can simplify, so ax, that just cancels out there, and then x plus 5. Okay, so a quadratic equation in factored form can also look like this. And if we have 0 and negative 5 as our x-intercepts, it can open up, it can open down. Let's go wider. It can open even wider. Okay, just as an example. Okay. And remember, because we're dealing with the a, this is still just a family of functions. Okay, and then 6 is the only x-intercept. So 6 is going to account for both the r and the s in this case. So we can rewrite this as ax minus 6 squared. And if 6 is the only x-intercept, okay, the vertex is going to be right at 6, 6 comma 0. So it can open up, it can open down, it can be wider. Okay, so there are 3 members of the family who has x is the only x-intercept. Or sorry, 6 is the only x-intercept. Okay, find the equation of a quadratic function with the given zeros and containing the given point. Okay, so this is specifically the equation. So, and then we're going to express in standard form. So we're going to start with y equals a, x minus r, x minus s. And we're going to go ahead and sub in the 2 and negative 2. So 2 is going to be for r, and negative 2 is going to be for s. Okay, we're also going to sub in x equals 0. So to both places where we have an x, we have 2 of them in there. And then y equals 3. So 3 equals a, 0 minus 2, 0 plus 2. And then we just simplify. So we get negative 2 plus 2, so it's negative 4. And then we divide out. Okay, so if we get a equals negative 3 over 4, our equation is going to be y equals negative 3 over 4, x minus 2, x plus 2. Okay, now this question wants us to express this in standard form. So what we have to do now is actually expand. Okay, so let's bring down the negative 3 over 4, and we're going to expand the two brackets. So we get x squared plus 2x minus 2x minus 4. Those two middle terms go away. We're left with y equals negative 3 over 4, x squared minus 4, and now we can expand in. So our equation is y equals negative 3 over 4 x squared plus 3. Okay, B, there's a double zero at x equals negative 2. So this is just like the last question, example 1, number 3, where we have one x-intercept, and it's going to account for both the r and the s. Okay, and then we have a point at 3 comma 10. So let's go 10 equals a 3 plus 2, 3 plus 2. 3 plus 2 is 5. So we have 5, 5. 10 equals 25a, divide out. Okay, that's just algebra. So we have a equals 2 over 5. So our equation is going to be y equals 2 over 5, x plus 2, x plus 2. And now we can put it into standard form. So let's go ahead and distribute this. Okay, distribute the two brackets first. X squared plus 2x plus 2x plus 4. Okay, we can collect those middle terms if you want in the next step. Simplify it a little bit more. And now distribute the 2 over 5 into the bracket. We get y equals 2 over 5x squared plus 8 over 5x plus 8 over 5. Okay, and that's the equation that goes through 3 comma 10 and has a double zero at negative 2. And I'm just going to move this up. Okay, so now we have 3 plus root 5 and 3 minus root 5. So where do we see roots such as these? Well, we see them when we use quadratic equation, right? So they come up. So let's sub them in. So exactly where r is, we're going to sub in 3 plus root 5. And exactly where s is, we're going to sub in 3 minus root 5. Okay, and in the next line, I'm going to plug in the 2 comma negative 12. But I'm also going to distribute the negative sign. So negative 3 minus root 5. and we have 2 minus 3 plus root 5. Okay, I'm going to simplify this just a little bit. So we have 2 minus 3, negative 1, and then minus root 5 is just going to stay there. And then 2 minus 3 again, negative 1 plus root 5. Okay, I'm going to go ahead and expand this. Okay, so I get negative 12 equals a. So what's negative 1 times negative 1? 1. And then we have minus root 5, and then we have plus root 5. And then we have minus, so if we do root 5 times root 5, we're going to get 5. Okay, those two cancel out. We have 1 minus 5, I get negative 4. Okay, so we get a equals 3. Okay, so let's bring this up over here. Y equals 3, bracket. Let's go x minus 3 minus root 5, and then x minus 3 plus root 5. And these are going to multiply. So x times x is x squared, x times negative 3, and then x times root 5. Okay, and then negative 3 plus 9 minus 3 root 5, and then negative root 5. I'm going to just continue it down here. Negative x root 5 plus 3 root 5 minus 5. So let's keep the 3 outside for a second. Let's add like terms. So we get x squared. Okay, I get negative 3, negative 3. So negative 6x, because this negative x5 and then plus this would be like x5. Those cancel out. And then this positive 3 root 5 and then negative 3 root 5, those cancel out. And then 9 minus 5, I get 4. Okay, so y equals 3x squared minus 18x plus 12. Okay, last question. The parabolic opening of a tunnel is 32 meters wide, okay, from side to side. At the points that are 4 meters from each side, the tunnel entrance is 6 meters high. So we can do this one of two ways. We can either put the middle of the tunnel in the middle of the x and y axis. So we can have 0, and then the actual x-intercept would be 16 and negative 16, which would make these points 4 in from 16 would be 12, and then negative 12. Okay, the other way we can do it, which might be easier, is to put the x-intercepts as 0 and 32. And then it says 4 in from each side, which would be 4, and then that one would be 28. We would go 6 meters high. So this one looks a little bit easier. Let's use this because we have that 0. Okay, so here's two different diagrams. You can use either one. Determine an equation of the function that models the opening to the tunnel. Okay, so for B, this is going to be A. So let's use factored form. So y equals A, x minus r, x minus s. Okay, in this one, we're going to use 0 and 32. Okay, x minus 0, x minus 32. And I'm just going to simplify this a little bit. So ax, x minus 32. Okay, but we know that we have 4, 6. So let's actually sub in 4, 6 and see what happens. Okay, so we get 6 equals, well, what's a times 4 times negative 28? We get negative 112. Okay, so 6 equals negative 112a, and divide out the negative 112. We get 3 over 56. Okay, so our equation is going to be y equals 3 over 56, x minus 32. Now find the maximum height of the tunnel to the nearest meter. Okay, so the 2 zeros would branch off, x equals 0. Oh, actually, I'm going to do this in a way that we don't need this scale. The maximum is going to occur between 0 and 32, so it's going to occur at 16. So what we're going to do is we're going to use our equation, and we are going to sub in 16. So when we multiply 3 times 16 times, this would be negative 16. And then divided by 56. Sorry, this is negative 3 over 56. Okay, we get positive 13.7. And let's go meters. Okay, so therefore, the max height is 13.7 meters.